Welcome, everyone, and thank you for tuning in to another Silicon Labs product podcast. Today, we are joined by Mark Hallam. He's a field applications engineer for Silicon Labs. And one of Mark's responsibilities is to support customers who are considering Thread for their products. Now, I thought it would be helpful for Mark to answer some of the questions that customers may have about Thread. Thanks for joining us today, Mark.
Sure. Good to be here.
Mark, over the last 2 years, I've heard more and more about Thread. What started off as a solution adopted by Nest has started to grow interest with other people. To start, how do you introduce Thread to people who aren't familiar with it?
So I'd probably break it down into a couple of components. For one, Thread is a mesh networking protocol. So for somebody who doesn't have a full understanding of how mesh networking works, the fundamental concept is that you're able to repeat messages throughout your network rather than having to have a direct link between every device in the network, and that's to promote reliability, robustness, and to some degree help with optimizing in terms of battery life and things like that as well. Thread is different than any of the other mesh networking protocols out there in that it doesn't define your application layer. And so fundamentally what that means is that while you can define your networking communication mechanism, you don't have the language selected for you. So you can basically choose any application layer that you want. That adds a lot of flexibility. It comes with some of its own headaches, and I'll talk about those in a little bit. Another thing about Thread that makes it particularly different is the fact that it does support IP. So most networking protocols out there, or most mesh networking protocols today, don't have support for IPv6, and that's one of the advantages of Thread, is that it uses networking protocols that are already established and have been used, and in some cases are easier to deploy just because they're built on technologies that are well known. So I think that's fundamentally how I would describe Thread. And then, of course, you have to add in that it does allow you to interoperate with a number of ecosystems that are currently deployed or being deployed today. Like you mentioned, Nest, and some of the new Nest devices, like this Nest Hub Max that was just released, is a Thread certified device.
Okay, well, so I mean, it probably is in the answer you just gave, but what are some of the other reasons, and why do you see the growing interest in Thread versus some of the other wireless protocols? Is it things beyond the IP addressability?
Yeah, I think there's quite a few, but I'll just narrow it down to a few. So first of all, one of the things that's driven adoption and interest in the past year or so is, first of all, Google's adoption of Thread as their standard for communication between all of their low-power end devices. Obviously, you mentioned the Nest ecosystem. But moreover, Apple also recently joined the Thread group. So I think that seeing two major vendors adopt Thread as their baseline has driven a lot of interest from a lot of the end device manufacturers as well. I think one of the things that you have to consider is that when you look at Amazon or you look at any one of these major ecosystem development companies, a lot of end device manufacturers kind of align with them because they want to be able to connect to as many of the major companies as possible. So Apple, Google, and Amazon are the three right now that most people want to find a way to operate with. And so I think that's driven a lot of adoption and interest. I would also say that there are some of the technical aspects as well. I mentioned flexibility about the application layer. Now, the networking layer is well defined, but with the application layer being undefined and having a defined networking layer, there's a big advantage there in terms of the amount that you could do with a device that you're creating. So the idea here is that you're fundamentally able to deploy infrastructure where maybe while the application layer doesn't have to be able to talk to each other, maybe you have light bulbs operating on one application layer and then other devices that can transmit sensor messages on another. They don't necessarily have to be able to understand each other for them to be able to route each other's messages. And I think that with a lot of vendors coming to market with their own devices that speak their own language, there's some advantage there for those guys to drive more adoption in their own ecosystems while still being able to use this infrastructure that's deployed. And the third thing, I think I mentioned this, but I'll harp on it a little bit more, is that because it's built on networking protocols that are much better understood, I think that more companies are who are more risk averse are open to evaluating it. When you start looking at something like a Zigbee or a Z-Wave, where you fundamentally don't have really access or understanding of how the protocol works, it can be a little bit of a risky venture, and I think that we're seeing that more and more as well. Okay,
Mark, is there anything else that may be a benefit that you see with Thread?
Yeah, so I think this ties into the flexibility at the app layer, but fundamentally, one of the key features of Thread is that the main device for getting out of the network is what we call, or we refer to as a border router. So the border router fundamentally is a bridge device that can take IP packets and transmit them out of the network. Usually there's some kind of IPv6 to v4 translation there. But fundamentally, that border router allows for a lot of flexibility in your network because it doesn't have to have the same rules engine logic in place that maybe a Zigbee coordinator or Z-Wave devices might have to have. The reason I say that is because with the border router fundamentally being a translator, essentially what it does is it just takes your packet and forwards it out to the greater internet. So with that, your border router can be fundamentally what I refer to as dumb. It doesn't have to have an understanding of what's in the packet or an understanding of the application layer that packet might be encapsulating. It fundamentally can just transmit that packet out to the network. And so what that allows you to do is connect a number of devices that don't necessarily have the same application layer to this border router and get those messages out and back into the network. That also means that any border router that's Thread certified has to have that same behavior. So while you might have to interact with the vendor for like a Zigbee gateway, you don't have to interact with the vendor nearly as much for a border router device because, like I said, it's fundamentally just a bridge or a tunnel.
That's great. So the whole IPv6, those were two really good examples that you gave, because although other mesh solutions have IPv6 solutions, it is, to your point, it goes up to the application layer, and then you have to have your separate IP solution, correct? Whereas with Thread, you don't need to go all the way to the app level. It's got IPv6 built in, and so it stops, and it can just bypass and go straight back out if necessary.
Yeah, exactly. So a lot of other protocols that have some mechanism of IPv6 addressability, it's not true IPv6. In other words, it's not native to the devices. So typically that's managed by that coordinator or gateway, and that's why I say that there's an advantage with the border router, because the border router isn't simply encapsulating a Zigbee message or encapsulating some mechanism of addressing a device with an IP address. It actually is forwarding those packets out to the network, and those devices can natively understand that. So in the case of some other protocols, and maybe I'd give Z-Wave as an example, it's not native IP. So those devices couldn't understand IP or be addressed by their IP address. There has to be some other device in between, like the zip gateway, that allows you to message those devices directly by understanding which IP address corresponds to that device's local personal address.
Sure, yeah, and that sounds like a huge benefit. But now let's talk about maybe some of the hurdles or the difficulties that Thread has. Thread versus the other solutions that we've already brought up. Can you explain some of those difficulties?
Sure. Yeah. Where do I start? So there are quite a few right now that I would say customers face when they get started, especially since it hasn't been widely deployed yet. That we're still in relatively early stages, and we're seeing a lot of adoption now. But the first one that I would say, and this is a clear challenge, is where do I get support? So the nature of Thread, at least at this point, there's only one Thread stack that's really widely available, and that's the Open Thread stack. The fact that it's open source means that most silicon vendors don't adopt, their own internal support team to answer customer questions and things like that. They basically say, hey, if you want to use this, here's our interfaces to our radio, and here's our interfaces to the rest of our hardware. Go have fun. So right now, there are not a lot of support people in place to answer your questions. But I think that over time, there's a couple of things that are happening. One, Silicon Labs is intending to provide certain levels of support, and what we're doing right now is answering questions in GitHub. You'll also see that some other vendors are also doing the same thing, answering people's questions in the GitHub or maybe in Stack Overflow and other places. But that's one of the first hurdles, and so I think that's why there's a great need to have more and more documentation as time goes on, because with it being open source, it's much harder for silicon vendors to get behind having their own support team for it. The second thing I might mention is owning your network, and I think this is true of really any mesh protocol, but in regard to Thread, if you don't own your whole network, then there's some questions about what you might be connecting to or what other devices might be available. So the reason that comes up is because, of course, if you're connecting a bunch of sensor devices directly to this border router to get out to the cloud, but you don't have any devices in between to route those messages, now you may have to deploy sensors all over a pretty large area and increase their output power and hopefully have a good sensitivity so that they can hear messages that are coming to and from that device. That, of course, is going to have a big impact on battery life. So that's just one example of why you need to have a fundamental understanding of what type of devices or use cases you're intending to connect to, because that's going to add a lot of complexity. The third thing I'd mention is ecosystem interoperability. So this is true really of Thread, Zigbee, Z-Wave, any other major mesh protocol, is what ecosystems am I trying to connect to? And I mentioned this a little bit earlier, that while Thread has an advantage in that you could actually have multiple ecosystems running on the same devices, because the application layer is really agnostic, there's a level of complexity in understanding who I want to connect to, when, why, and really how I'm going to do that with the limitations that I have in an SoC, which is flash and RAM and things like that. So yeah, I think a big component of that is understanding the network that you're actually trying to connect to. I mentioned the application layer, and actually that's been one of the things that's held back Thread at a really massive scale, and that's because nobody's really determined what application layer should be used as the primary app layer for Thread. Although that flexibility is advantageous, eventually people want to decide who they're actually going to be talking to. And when you do that, when you have some complexity there, it really slows down the ecosystem adoption. And then the last thing I'd mention is really true of any 2.4 gigahertz protocol. There are other protocols like Z-Wave that don't operate in this band, but coexistence is a big problem today, and I think it will be for a while. But we actually have solutions to address coexistence, and we can always talk about that at another time.
Okay, well, that leads me to my last question. Is really where can customers get started? Learning a little bit more about Thread, learning a little bit more about Silicon Labs solution. We'll have another podcast to go into deeper details, but maybe for the end of this podcast, you can just tell the listeners how you'd suggest they get started with Thread and learn more about Silicon Labs' particular solution. Sure.
Yeah. So first of all, if you're looking for information on Thread, there are a couple of pretty easy places to go. One is to go to openthread.io. which is the OpenThread website. It does have guides and reference manuals and so on. It also has a link to the other site I'd recommend looking at, which is github.com/openthread, which is where you'll find a number of examples that run on our SOCs today. You'll see lots of questions that people are asking, and you'll see that they're actually getting their questions answered. And lastly, in understanding Thread itself, I think it's valuable to have a copy of the Thread spec. So I'd recommend going to threadgroup.org and signing up there and getting a copy of the spec so that you can read it and have it as a reference.
Great. Well, that is it for this episode, Mark. Will you stick around and join me? I have a couple more, maybe a little bit more technical questions that we can cover.
Sure.
All right. Well, thanks, listeners. Stay tuned for our next episode where Mark and I will go into more details on OpenThread. Otherwise, have a great day.